relations as functions,
A lot of these notes
or relations and functions.
I like that though.
Do you want them to be longer?
No,
I was going to say, be careful what you wish for, because when you get to trig, they're not short.
I was just looking.
Okay, so the first problems, they have multiple things that you are finding. So something that I'm finding with my classes is if they have multiple sets of instructions in one thing, people don't do them all. So I'm going to write out what we're going to be doing. First of all, we are going to identify the domain and range. So that's the first thing. Then the second thing is we are going to represent the relation using a graph. And you don't need graph paper. And then 3, we're representing using a mapping diagram. So depending on if you think of domain and range as like one thing, because like typically you're not just asked for one or the other, you're usually asked for both. You need 3 separate things. If you think of domain and range as 2 separate things, then you should have 4 total things written down on your paper, okay? So what I like to do is like on a quiz or a test, if that's the instructions, I would underline everything that you need so that you make sure you get it all. I would say the most common thing that people get wrong in this when it comes to a quiz or a test is just flat out not doing all the pieces. Okay, so just make sure that you pay attention. Again, I'm doing this because I copy the instructions from the textbook. I don't change them. They're the exact same instructions. So just make sure you pay attention to what it's asking for. So they're going to give you some number of ordered pairs. Most of them look like they have 4. So number 6 is -7, 4, 2, -5, 1, -2, and -3, 6. And so the first thing we're going to do is identify the domain and range. So the domain are my x values, range are y values. So the domain, and a lot of times I just abbreviate it with D and R, is we copy down all the x values. Now, ideally I like them in numerical order. If you don't do them in numerical order, not going to take off, but it would be -7, -3, 2, and 1. Or I guess I should say 1 then 2, but I want numerical order. Range are the y values. So we've got -5, -2, 4, and 6. Now, if a number is repeated either in the domain or the range, then I am only going to write it one time. Okay? So if I have, say if -7 was an x value twice, I'm only going to write it once. So just make sure you're aware of that. So that's the first thing. Then they want me to represent using a graph. So I'm going to set up a little graph here. I need to make it a little bit more. Well. All right, so the x values go from -7 to +2. So I'm not, whatever. Y values from -5 to 6. And as long as you're counting in increments of 1, I don't care if you say that, if you label the different points on your axis. If you're counting by something other than 1s, you need to at least specify on one of them that you're counting by 2s or something like that. So then I'm going to plot each of these points. So -7, 4, go left 7, down 4, or up 4, I mean, +4. Whoa. What just happened? That was weird.
Is it the auto thing?
I don't know. It just shifted everything. It was very weird, but I fixed it. All right, then 2, -5. Then 1, -2. And then -3, 6. So if you want to use graph paper, you're obviously welcome to, but you really don't need it. We're just plotting points, giving a rough visual of what it looks like. All right, then the last thing is we're using a mapping diagram. Okay, this is probably the next place that people get points off. A mapping diagram is labeled with input output. Okay, sometimes people will go up here and they'll write domain and range, and then that's why they won't write it all. Okay, because they'll be like, well, I did my mapping diagram and my domain and range at the same time. That's not how it works. You write everything separate. So again, we put them down in order: -7, -3, 1 and 2. Output: -5, -2, 4 and 6. Circle the two columns of numbers. And then we are connecting with what they go with. So -7 goes with 4. -3 goes with 6. 1 goes with -2. And 2 goes with -5. So each input value can be used only once for it to be a function. That's not what this is asking. That's probably the only thing that will be slightly different when you get to your quiz or your test. A lot of times, instead of having you do like multiple problems, I'll go ahead and ask you then, with this, is it a function? Okay, so just for reference, this one would be a function because each input is used only one time. Let's see. Identify, tell whether the relation is a function, explain. So 10, they give us a mapping diagram. And these are just given to you exactly: -6, -4, -1 and 2, and then output 5, 2, 1, and -1. So obviously they didn't write their numbers in order, but it's fine.
Why do you circle?
That's just how they look in the book. It's kind of just to show that it's what goes like together in the column. They do like a square round box. Looks like a square with like rounded corners, but and they just have them going across like this. And all we're doing on this one is saying if it's a function or not. So each input is used exactly one time, so this one would be a function. Now, if it is a function, I'm not as worried about your reasoning. If it's not, you should say why it's not. Okay? Because they say to explain, but if you want to write the reason, obviously, that's fine too. 12. Again, these are given to you this way. Input -1 and 5. Output is 4, 2, -1 and 3.
So for these, we don't have to graph them?
No. These ones just ask for you to tell if it's a function or not. Yeah, so anytime there's more outputs than there are inputs, that should be an automatic, not a function, because we can't have that. So this one is not a function. You can say there's more outputs than inputs, or you can say each input is not used or is used more than once.
Your room is a lot cooler than this pattern, I feel like.
Today. People keep coming in my room, and I haven't figured out who it is yet. but they keep coming in and they turn the thing all the way down. So the other day, I always leave it pretty much like right where it is, unless like a lot of times after lunch it gets cold, so I would turn it up like a tiny bit. Although since I have a really big class that comes in after lunch now, like it doesn't get as cold as it did last year when I had 2 people coming in after lunch. But anyway, so I pretty much leave it there. And the other day I was like, why am I freezing? And I looked and somebody had taken it and turned it all the way down. I was like, and that was the second time that day that it had happened. So I could not figure out who was doing it. I was like, what is going on?
Who's Kelly? No, Kelly's too short for Rachel.
Like sometimes, like I would have like in previous years or something, I would have a student sitting back there. If it was like too cold or too hot, I would have them like adjust it. But I'm like, this is like dramatic.
I remember when we were in, what this Kelly teaches? Geography. She'd be hot, so she'd be like, Abby, go to your dad's room and turn it all the way down. So she would.
Oh yeah.
No, we'd be freezing. She's like, it's so hot in here.
She got a little deck fan.
Yes.
She has a
All right, now, if instead, let's say this set of numbers was flipped and there were more inputs than outputs, would it be a function or not?
Function. I don't know, function. It's both. I don't know.
Can't be both.
Because, yeah, because.
Can an output be used more than once?
Yes.
Yes, an output can be used every single time. Just the inputs can't be repeated. Okay? All right, so some of the problems are going to say, tell whether the relation is a function and explain. Okay? So that's basically what this just said, but these gave you mapping diagrams. They also could go back and just give you something like this. This is why I said a lot of times within this question, I will just go ahead and ask you, is it a function or not? For the sake of like saving an extra question. But if they give us that, we can use any method to show whether or not it's a function. Okay, my favorite is probably the mapping diagram because it's just really easy to see. But you can also use a graph and do the vertical line test where, so like what that would look like with this one with it graphed, is as you go and move your pencil across this way, if there's only one dot at each spot, then it passes the vertical line test and it's a function. Okay, if you had a repeated input value, you would end up with 2 things basically as you pass through it, and it would not be a function. Okay. So, like if I graphed this one, it would intersect my like pencil twice, and that would automatically tell you that it's not. So, with one like 18, just telling if it's a function or not, they give us the points 0, 1, 1, 0, 2, 3, 3, 2, and 4, 4. All right, so when it's asking you this, you need to show one method that it is or is not. Okay, now you can also do it with domain and range. If there are more range values than there are domain values, that would be another way of showing that it's not a function, because that would be the same thing like your inputs and outputs. But I like the mapping diagram, so that's how I normally do it to show it. And so input values are 0, 1, 2, 3, 4. Output values are also 0, 1, 2, 3, 4. And then I just connect what they go with. So 0 to 1, 1 to 0, 2 to 3, 3 to 2, and then 4 to 4. So each input value is used one time, so this one is a function. Okay, so that's sufficient for showing that why it's a function there. If it wasn't, then I would explain that each one is used more than once. Now, the only thing I'm going to caution you with of purely just looking at are there more outputs than inputs, outputs can be used twice. So just because they have an equal number does not mean that that it's automatically a function. Okay, you've got to look at what is being used, because an output, if it's used twice, we only write it once. Okay, so just make sure you watch for that as well with those. Okay. This is for numbers 21 through 23. I would not be inclined to give you one like this on the quiz, but just for the sake of us seeing the vertical line test, it says to use the vertical line test to tell whether the relation is a function. So if they gave you a graph that looks something like this, kind of looks like a, I don't know, sideways S. They want us to tell if it is a function or not. So as we pass through, in every spot, there's only one place that that line is intersecting with my pencil, and so this one would be a function. Another example, if we had something like this. This is not, because at pretty much every point it intersects more than once, so this is not a function. What if I had like the graph of a circle? Nope, because it intersects twice, so this one would be not a function. All right, the last stuff in this section, okay, there's some of just like simply graphing lines. I usually just skip over those. So I would hope by this point you know how to graph a line. Tell whether the function is linear. Okay, what does that mean?
Linear.
It's a line.
No.
Okay?
What?
So, what form does a line take on?
Straight line.
Like, what is the equation of a line? Y equals mx plus b. Now, b can be 0, so I could just have like y equals x, and that's a line, right? If x is raised to a power, is it a line? No. X has to be by itself, okay, or a number in front of it. If it's in absolute value bars, no, it's not linear. If it's under a square root, no, it's not linear, okay? So you're probably like, why is she being so dramatic about this? Because every year I give one that's very clearly not linear and the class tells me it's linear. If it doesn't graph a line, it's not linear, okay? So they say to tell whether the function is linear, then evaluate the function for the given value of x, okay? So they'll give you like an equation, and then that'll say like f of x is equal to, and it gives you something, and then it'll say f of whatever, so we're going to evaluate. Even if it's not linear, we're still going to evaluate, okay? So the first one, number 34. F of x equals x plus 15. And I'm going to go back up here and say f of x here, because f of x can be used interchangeably with y. If we're doing it in function notation, that's just because that's telling us that we're going to be plugging something in like that. And then they tell us that we're going to be plugging in, it'll be f of 8. Okay, so is this linear? Yes, it's an mx plus b.
Yeah, because x is by itself.
Yes, x is by itself. It's not raised to a power, not under a radical, not in absolute value bars, nothing. Okay? So this is linear. Okay, you don't need to graph them. You can if you're unsure if it's a line or not. That is linear, and then we're going to evaluate for when x is 8. So f of 8 means anywhere there's an x, I put an 8. So this is 8 plus 15, and that gives me 23. So this is linear, and the value is 23. All right, 36. F of x is equal to the absolute value of x plus 10. Is this linear? No. So this is not linear. Now, Even though it's not linear, I'm still going to evaluate f of negative 4 is equal to the absolute value of negative 4 plus 10.
What's that?
It was the verse and stuff that was hanging on the wall last week.
What verse?
It was hanging back there, but it's not there anymore.
So what do I do?
Nothing, it's just extra credit.
Extra.
I didn't know there was something hanging on the wall. There was something hanging on the wall.
Well, so they did.
All right, what's the absolute value of negative 4? You can just set it over there somewhere, just not on the donuts.
Oh my goodness, if she was doing a speech to him.
Absolute value of negative 4 is 4. 4 plus 10 is
Oh wait.
14.
Which is not linear.
Yeah, well, we already said that.
Shut up, dude.
Give it to us. Send me again.
38. After the tests that are given tomorrow, I'll put a new one up. G of x is equal to x cubed minus 2x squared plus 5x minus 8, and then g of negative 5. Is this linear? No, because x is raised to...
Power of 3, 2.
Yep.
It's cubed and squared.
This would be a cubic function. Okay? So this is not linear, but we still evaluate g of negative 5 is negative 5 cubed minus 2 times negative 5 squared plus 5 times negative 5 minus 8. Negative 5 cubed is
Negative 125.
negative 125. Negative 5 squared is 25 times negative 2 is
This negative 50.
negative 50. 5 times negative 5 is,
Negative 25.
and then minus 8. So what is that?
A lot.
Negative 208.
Negative 208.
What do you mean? Holy cornball, it's simple math.
Is it?
You just add them all.
All right, any questions on this stuff?
Nope. No.
All right, maybe y'all will finally be my class that can tell me if something's linear or not.
Don't worry, guys.
Now, one other question, just because this might come up too. If you had f of x is equal to negative 22, is this linear?
Yeah.
Yes. Because that would be like y equals that, and we would just have a straight line going across a horizontal line at negative 22. Okay, so this would be linear, just for reference. Some people don't get that one either, so that's why I like to point that out. All right, problems. I'm not giving you a lot. I'm giving you basically like one of each type. If you feel like you need to do more, then you should go back and obviously do more. 5, 11, 17, 21,
And then I'm gonna make you eat it
and
I'm there for a day.
I'm so confused.
I'm threatened. I'm so
35 and 39.
Oh yeah.
What?
I'm overstimulated with what you just said.
Now, I'm not giving you any of just graphing a line. If you don't remember how to graph a line, you should do a couple problems from 25 to 33. Okay? There could be one where you just need to flat out graph a line on the quiz, but I'm trusting that you know how to do that from Algebra 1. So, I'm not giving you one, but if you don't remember, you need to do that. Because the mapping diagrams can take up a lot of space, if you want to copy them over when you do your problems, you can. If you don't, because they're taking up space, which is really just number 11, you don't have to copy it over. That's like my one exception. And the graph of 21, I don't care if you copy that onto your paper either. You can just tell me if it's a function or not.